Okay, stats. The next session is the multiplication rule and independent events. Two events are independent if the first one has no effect on the second one, and really vice versa. They could be interchanged. For example, if the first event is a coin is tossed, and the second event is the coin is tossed, does getting a heads or tails on the first coin affect your chances of getting a heads or a tails on the second one? No. So the probability of event A and B occurring is probability of E times the probability of F. So think of a spinner. What is the probability of spinning a 7 first? So what are the chances of getting a 7? 1 out of 8. And a 6 next. Another 1 out of 8. When you multiply them together, it's 1 out of 64. Because in reality, it's pretty hard to get a 7 first and a 6 second. I mean, you're really depending on both things going right. So think of every way you can spin the spinner. Twice is listed on the right. There's 64 different possibilities, and only one of them was 7 than 6 down here. So what about the statement a 2 first and a number greater than 5 second? So there's a 1 in 8 chance of getting a 2, and there are 3 numbers greater than 5. You multiply them together, it's 3 out of 64. So that'd be 2, 6, 2, 7, and 2, 8, which are these 3 down here. A coin is tossed 2 times. What is the probability of getting 2 heads? Chances of getting heads the first time are 1/2. Second time also 1/2 for a total of 1/4. And lastly, a family has 9 girls in a row. Find the probability of that happening. It'd be 1/2 times 1/2 times 1/2 9 times. Now you don't want to write that out every time. If you're multiplying the same number over and over, remember you can raise it to an exponent, 1/2 to the 9th, 2, 4, 8, 16, 32, 64, 128, 256, 5, 1 out of 512. If you need decimals, you can of course convert these to decimals in your calculator. We can leave them as fractions. We tend to like probability better as fractions, but it's not wrong if you turn them into decimals. Okay, so let's go to the next page. If the probability that South Florida will be hit by a hurricane in any single year is 5 out of 19, what is the probability that South Florida will be hit by a hurricane in 3 consecutive years? Well, year 1 is going to be 5 out of 19. Year 2, 5 out of 19. Year 3, 5 out of 19. Or 5 out of 19 cubed. So either as a fraction, this is going to be 125 out of 6589 or 6859. Or if you put this in the calculator and you get a decimal, you'll get 0.018. What are the chances it will not be hit by a hurricane in the next 10 years? So let's think about the first year. If you have a 5 out of 19 chance of being hit by a hurricane, not being hit by a hurricane is the opposite. So it's 1 out of 5 out of 9, 1 minus 5 out of 19, which is 14 out of 19. And to do this 10 years in a row, it would be 14 out of 19 to the 10th. So this is where your calculator comes in handy. 0.047, which is only about a 5% chance, which makes sense. I don't see Florida going 10 years without getting hit by a hurricane in this lifetime or any other. Dependent events. 2 events are dependent if the first event does have effect on the probability of others. So picking 2 cards out of a deck without replacing. For example, if you get an ace in your first card, you now have fewer aces in the deck, so it becomes harder to pick an ace in the second card. One thing that tends to happen, getting an A on the first test, does it increase your chances of getting an A in the class overall? Well, yes. So let's just talk about determining whether or not E and F are dependent or independent. Drawing a heart and rolling an even number. Can one of those affect the outcome of the other? Probably not, so I would say they're independent. Speeding on the interstate and being pulled over by a police officer. Now, some would say those have nothing to do with each other. I would beg to differ. These are dependent. Batteries in your cell phone are dead and batteries in your calculator are dead. I think this could go either way. Your batteries in your cell phone have nothing to do with the batteries in your calculator, but if you're a generally irresponsible person and you let your cell phone die, you're also probably the type of person who might let your calculator die, so there could be a little correlation. But I would say generally these are independent. We'll try to avoid ones that are murky territory on the test if possible. Let's continue. So, general guidelines. When you're trying to decide between or and, these are your general guidelines. You're using an or formula if it has the word or in them. You're almost always going to do this if you're making a single selection and you have multiple groups that could be selected. And if one person is selected, find the probability the person is a man or a Canadian, for example. And problems may not have the word and in them, but they involve more than one selection. You're choosing one thing and then another. And if two people are selected, for example, find the probability that both are men would be the type of one. So the first one's a man and the second one is a man. So we'll continue in the next video.